So good day everyone. I am here to teach you about the basic integration formulas. But first, before we proceed to the basic integration formulas, we need to define integration. So what is integration? Integration could be algebraic, exponential, logarithmic, trigonometric, and many more. There are also applications of integrations which we will tackle in the future. Some examples are areas, volumes, and many more. So, there are two types of integration. Two types of integration. First is indefinite, which we will tackle now. So, indefinite integral. Indefinite integral is indicated by the integral of f of x dx. And another type of integration is definite integral. Definite integral. Definite integral could be determined by having a limit which can be indicated by the limit from a to b f of x dx. So between these two, you can easily find the difference between indefinite integral and definite integral. Indefinite integral has no limits, while definite integral has limits from a to b. So, integration is just the reverse of differentiation. Now, moving forward to the basic integration formulas. First, we are about to tackle the algebraic function. So, first type of integration formula, algebraic function. First, we have the integral of 0 dx. So we all know the integral of 0 constant dx is just equals to c, constant 0. Second formula, we have the integral of a here is a number, dx. So the integral of this a dx is just, first we need to put out the constant outside, then dx. The integral of dx is just equals to x, 1 dx or x. So 1 dx equals x. It's just equals to ax plus c. Don't forget to put c here because it's a constant. Number 3 formula, we have the integral of ax dx. So the integral of this is just x plus 1 here, x, and here is the exponent, and x plus 1 over n plus 1. So a, since the exponent is 1, we add 1, that becomes 2, ax2, and we bring down the 2, we also copy 2 and n plus 1. So the exponent of x here is 1, it's just 1 plus 1 equals 2 plus c. Number 4, we have axn dx. As I said earlier, we put out a here outside, the integral of x n plus 1 here over n plus 1, and here's the exponent, guys, remember, and equals to a, this is a, x plus 1 n plus 1 over n plus 1 plus c. So, did you notice what formula did we use here? Yes, that is the power formula. Power formula. Okay, is it clear? Now we move on to the examples. Okay, example number 1. Here we have examples. Number 1, the integral of 4x dx. So, as we all know, we take out 4. The integral of x here is just 4x. 1 here is exponent. Is it clear? 1 plus 1, 1 plus 1. That's equals to 4 times x squared over 2. So we bring out 2 here, that becomes 1/2 to 2. So 1/2 of 4 is just 2, or we could just cancel out here 2 and 2. And our answer is just equals to 2x squared plus c. That's our answer. And number 2 example here equals to integral of 3x squared dx. So 3x squared is, we bring out the constant outside, then the integral of the x squared plus 1, and the exponent here is 2, so 2 plus 1 equals to 3 times x cubed over 3. Since 3 times 1/3 is just, let me check, let me clarify here. 3 times 1/3 is just equals to 1. So we cancel out this part, cancel 1 is 1 1. So our answer here is x cubed plus c. Last example is just 3x4 x raised to 4 minus 2x6 dx. So we separate this by using this 3x4 plus 1, exponent here is 4, so we bring down 4 here, plus 1 minus 2, the integral of x plus 6 h to the 6 plus 1, integral, the exponent here is 6, so we bring down 6 here, plus 1 also. We put here, so 3, not enough space, we put it here, so 3 times 4 plus 1 just to 4 plus 1 is just equals to 5, x 5 over 5 minus 2, so 6 plus 1 here is just 7, x raised to 7, it's not integral, this is parentheses, x 7 over 7. So by simplifying this even further, our answer is just equals to 3 over 5 x raised to 5 minus 2 over 7 x raised to 7 plus c. So that's all for algebraic function. We move on to next part, which is logarithmic function. So here we are back with logarithmic function. So the principle of logarithmic function is that ln of x raised to a can be rewrite as a times ln x. So the integral, so the formula for logarithmic function is just the integral of ax dx is equals to, is it here, is equals to a ln of x plus c. So this is just the formula for logarithmic function. Now we move on to the example of logarithmic function. So I have here some examples of it. Example number 1 is for the integral of 4x squared x cubed plus x minus 2 over x. So this is mixed, guys, as we already learned the algebraic function as I discussed before. So time to integrate this. So it just equals to 4 the integral of x cubed plus 1, since its exponent is 3, we will also break down 3 plus 1 plus the integral of x 1, since the exponent is 1 plus 1 over 1 plus 1 minus 2 integral of 2 over x. So first we need to integrate all of this. Let's do that here. X equals to 4. So 3 plus 1 is just equals to 4. So times x raised to the 4th over 4. Since 4 and 1/4, we just cancel that out. Since 4 and 1/4 times 1/4 is equals to 1, we just cancel that out. What we left is x raised to the 4 plus x squared over 2 minus. So guys, what do you think the integral of 2 over x here? Here, the constant a over x dx is equals to constant ln of x plus c. So the answer of this is just really easy. So 2 over x is just equals to ln of x. Okay, so 2 ln of x plus c. Let me simplify this. Equals to x raised to the 4th plus x squared over 2 minus 2 ln of x plus c. So this is our answer to this problem. Integral of 4x cubed plus x minus 2 over x. So number 2. Number 2 here. Let's put there. Number 2. So number 2, we have the integral of 7 over x plus 1. So what do you think dx? Don't forget to put dx here with respect to x, of course. So what do you guys think the answer for this problem? Recall the formula, or do not memorize the formula, just familiarize with it. Okay, so here integral of ax dx is equals to a ln of x. So as you all know, now we know how to solve this. So it is just equals to 7 ln of the denominator here is x plus 1. f plus c. That's our answer. Easy, right? Oh, one last problem here. Number 3. Number 3 here. The integral of 5 over 3x plus 6. So, what do you guys think we'll do here first? Yes, that's correct. We need to factor the denominator. So, the square root of 5 over, the common factor here is 3. So, bring out 3. 3 divided by 3 is just 1, or x, plus 6 divided by 3 is just 2. Okay, 2 dx. Now, we bring out the constant. Okay, bring out the constant 5 over 3. Then the integral of 1 over the over left here. What is left here is just x plus 2. So we all know that a over x dx is equals to a ln of x. So the answer for this problem is just equals to 5/3 1 over x plus 2 just equals to ln of x plus 2 plus c. That is our answer. Easy, right? So we are going to proceed to another formula, which is the exponential function formula. So we are back with exponential function formula. First, we need to recall the derivative first, or differential calc. So recall d over dx of e raised to b x is equals to b times e raised to b x. So this is our derivative formula. Now we are in the integral formula, and I will show you how to do it. So putting here comma, though the integral of e raised to bx dx is just equals to e raised to b x over b here is constant, so whatever the constant of e raised to whatever that is, we bring it down, b plus c. So this is our formula for exponential function formula. So examples. First example is just equals to the integral of e raised to 2x dx. So by recalling the formula, by the way, note, don't memorize the formula, just familiarize with it. Okay, so the integral of e raised to bx dx is just equals to e raised to bx all over b plus c. So we're gonna do that. So the integral of e raised to 2x dx is just equals to e. Let's copy the value here, the function e to x, and whatever the constant here, you just bring it down. So 2 plus c. That's our answer for number 1. It's easy. Now we proceed to number 2 example. Number 2. So we have the integral of of 1 over e raised to 5 x dx. First thing we do here is to rewrite the function. So by doing that, we need to raise this function to the upward. So the integral of, since we move the value here, we need also to change its sign. So it's negative, so e raised to negative 5 over x dx. So now we are ready to integrate this by using the formula. So the integral of this is just e, just copy it, e raised to 5 x, whatever the constant here, we bring it down, okay? So e raised to negative 5x is also over negative 5 plus c. That's the answer for number 2. So number 3 here. Number 3, the integral of 3 raised to x dx. Okay, you notice, right, there is no e here in number 3. So what we need to do first is to equate this to y. So y equals to 3x, 3 over 3 raised to x equals to ln of y, ln of 3 raised to x. So by doing this, ln of y equals to x times ln of cube, and then is equals to y is equals to e x ln of 3. So we have here our new value. So we're gonna rewrite this to this. So it becomes e integral of e raised to x ln of 3. So dx. So what do you guys think we need to do here? Of course, we need to copy it first, because that is the e raised to bx. So that's equals to e raised to bx over b. So we need to copy it first, e raised to x ln of 3 over, what do you guys think the denominator here? Yes, you're right, ln of 3. Why? Because that's how it is, okay? Ln of 3 plus c. So that is our answer for problem number 3. So next topic we are about to tackle is about trigonometric function formula. So let's get to that. So welcome back to trigonometric function formulas. So first we need to recall the derivative of each trigonometric function. So first, recall. So the derivative of sine x sine bx is just equals to b cosine of bx. Another is the derivative of cosine bx is just equals to negative b cosine sine, I mean, let's erase that sine sine of bx. Another derivative we have here is just a derivative of tangent bx. So we all know the tangent bx is just equals to b secant squared bx. Another derivative we have here is equals to cotangent bx. Cotangent of bx is just equals to, the derivative of that is just equals to negative b cosecant squared bx. Okay, then we have the derivative of secant bx, I mean, equals to b secant of bx tan bx. I didn't realize my camera was tilting, so sorry for that. B secant bx over and tangent bx. Another derivative we have here is the derivative of secant bx, just equals to b, let's copy the secant, b secant of bx tan bx tangent bx. And lastly, we have the derivative of cosecant bx. So derivative of that is just equals to negative b cosecant bx cotangent bx. So as you see in our paper here, what do you guys think of the common or something here, something that is to our eyes? So let me rebuild that. All cofunction here, cofunction, cosine, cotangent, and cosecant, all of them, their derivative is equals to negative. So the principle of this cofunction, all cofunction is just equals to the negative of its derivative. So we move forward to the integral of this function. So let's do that. Let me flatten my paper here. So the integral of sine bx dx is here. Sine bx dx is just equals to negative cosine, I mean, bx over b plus c. That is our first derivative. First integral, I mean, integral trigonometric function formula. So next integral we have here is cosine. By the way, this is not an example. I will give examples later after I finish putting each trigonometric formula. Okay, cosine. So cosine, the integral of cosine bx dx is equals to sine bx plus c over b. Next we have the integral of secant squared bx dx. The integral of secant squared bx is just equals to tangent bx over b plus c. Another here is just the integral of cosecant squared bx dx is equals to negative cotangent bx over b plus c. So another here we have the integral of secant bx tan x bx dx. So by looking to our derivative here, the formula for derivative, the derivative of secant bx is equals to b secant bx tan x dx. So remember guys, integral is just the reverse of differential, or yes, differential calculus. Okay, so the integral of this is just equals to secant bx over b plus c. And lastly, the integral of cosecant bx cotangent x or bx dx. This is just equals to the negative cosecant bx over b plus c. So this is our formula for trigonometric function. Okay guys, so we proceed to the example. Okay, let me get a new page. We put your example here. Okay, so example for trigonometric trigo function. Example. So example number 1, we have here the integral of sine 4x minus the cosine of 3x dx. So recall the formula for each function. So the integral of sine bx of sine 4x. So let me erase this first. Integral of sine 4x is equals to, remember guys, the integral of sine is equals to negative cosine. That's right, negative cosine 4x over, don't forget, okay, 4 minus the integral of negative cosine is just equals to wait, negative cosine is equals to negative sine. Right. Yes, negative sine 3x over 3 plus c. Okay, so this is our answer for problem number 1. Let's proceed to problem number 2. Problem number 2. We have here the integral of cosine 5x plus sine of 2x plus the integral of cosecant squared 4x dx. So the integral of cosine is just equals to sine. So integral of cosine is just sine. Sine 5x over 5. By remembering the formula, let me show you the formula here. So the integral of cosine bx is equals to sine bx over b plus c. So I remember, guys, don't memorize the formula, just familiarize yourself with it, because memorizing isn't helping. Sometimes it helps, but you forgot because you just memorize and not familiarize. Okay, so back to the problem. We have here sine. Okay, so the integral of sine 2x is just equals to negative, so plus and minus, that becomes negative. Negative cosine of 2x over 2 plus, wait, okay, it's plus. So the integral of cosecant squared, as we recall, is just equals to negative cotangent. So plus and minus will become negative. So put in negative cotangent of 4x over 4 plus c. So this is our answer for problem number 2. So that's all for today's basic integration formula. So by recalling, our formula is just algebraic function 1, algebraic function 2, logarithmic function 3, exponential function, and lastly 4, the trig function. So next topic, we are about to tackle the general integration formula. So welcome back to my lesson. So today we are going to tackle general integration. So in this topic, in the end, we will be able to use and solve the problem by using the principle and concepts, and another is to master each problem using U-Substitution. Okay, so first we are going to discuss the formulas. So we all know the general power formula, that is equals to number 1 here is general power formula. Wait. To general power formula. So U du is just equals to u raised to n plus 1 over n plus 1 plus c. So this is the general power formula. General power formula. Okay. Next formula number 2 here is about logarithm. So we all know that du over u is just equals to ln of u plus c. Don't worry, we will have more example of this later. So third formula here, we have the exponential. So e raised to u du is just equals to e raised to u plus c, or a, or the integral of a here is constant, guys, remember, a raised to u du is just equals to au over ln a plus c. So these three formulas will help you a lot in dealing with our examples and for your future problems. So we have here our first example. Example number 1. So we have here the 2 square root of, just erase this for a moment. Number 1. We have here the integral of square root of 3x minus 4. Let's change that 4 to 6. Okay, let's change that to 6. 3x minus 6 dx. So first step, we will determine the u. So the u here is 3x minus x u. Now we find its derivative. So du here is the derivative of 3x minus 6. So what is the derivative of 3x minus 6? So we all know, if a constant is about, if we derive a constant, that will equals to 1 or dx. So why here is the derivative of 3x is just x 1 minus 1. So by doing that, our du here is 3 dx. So dx here, but we have an excess here. Let's call that balancing factor, or BF. So if your du is a common or a whole number, just reciprocal it, that will become 1/3. So balancing factor is 1/3. So equals to, now we solve this problem. So put your balancing factor here outside. Don't forget this balancing factor. Okay, so 1/3 the integral of square root of u dx du. So 1/3 times u square root of u is just u raised to 1/2. So u 1/2 plus 1 over, by using the general power formula, 1/2 plus 1. Okay, so 1/3 times u 1/2 plus 1, let me show you guys, is equals to 3/2. So 1/2 plus 1 is equals to 3/2. So 3 halves over 3 halves. So we need to put the denominator here outside and reciprocal it. Okay, then we put the answer here. 1/3 times 3 halves, reciprocal it will become 2/3. U of 3 raised to 3 over 2. Now, by calculating this simply means this equals to 1/2 times 1/2 times 2/3. 1/3. Sorry, 1/3 times 2/3 is equals to 2 over 9. Okay, 2 over 9. Now we substitute the u here. We substitute the u back here. Okay, then 9 times 3x minus 6 raised to 3 over 2 plus c. Don't forget the plus c, or the arbitrary number. So this is our answer for example number 1. Example number 2 here is, let me think of an example. So the integral of e raised to 2 minus 3x. So by you can determine your u if example here in number 1, you can determine the u by inside the square root. Okay, and here in number 2, you can determine the u in its exponent. There are also other cases where the u is found on the denominator. Okay, so u here is just 2 minus 3x. Okay, 2 minus 3x. So the derivative of this is just 2 here is just a constant, so dx. So our du here is negative 3 dx. So dx here, oh, we forgot to put dx here. So dx here and an excess of negative 3. So by reciprocal, this is equals to negative 1/3. To balance, or in other terms, you put 3 here and you put 1/3 to balance the equation. So this is just easy. You just need to reciprocal a whole number, while if your du is equals to 1/3, you reciprocal it, and that's 3. Okay, moving on to 2 here. So we put the balancing factor outside, then we integral of e raised to u plus e raised to u dx, dx equals to, so we all know here in e raised to u du is just equals to e raised to u plus c. So let's do that. Negative 1/3. The derivative of this is just equals to e raised to u plus c. We substitute back the u here, okay, to its original equation. So the final answer is equals to negative 1/3. Negative 1/3 e raised to 2 minus 3x plus c. It's easy, right? So moving on to the third example. Okay, let me think of a problem. Okay, so the integral of x dx over over 2x cube, x squared dx over 2x cube plus 3. So, as I said earlier, u here can be found in the denominator. So let's do that. U is equals to 2x cubed plus 3. So the derivative of this is just equals to 2 du. Derivative is transfer the exponent to the constant. That makes 6 x squared. 3 here is constant, so dx. So there is a balancing factor here, that is 6. So reciprocal of 6 is just 1 over 6. Or you can put here 6 x squared and put here 1 over 6 to balance the equation. Okay. So we copy the balancing factor 1 over 6. Then the integral of, so the du here is x squared dx, so could be also found here x squared dx. So du over u here is 2x cubed plus 3 u. So we all know du over u is just equals to ln of u. So 1/6 ln of u plus c. We substitute u back to its original equation. So 1 over 6 ln of 2x cubed plus 3 plus c. So this is our final answer. Okay, next example is the last example. Number 4 example. Number 4. Okay. Number 4 here is the integral of x. Let me get a clear look of my paper. X e raised to x squared or x cubed dx. Oh, x squared I mean. Oh, let's change that to x cubed e raised to the 4 dx. So as I said earlier, your u can be found in square root. Can be found in square root in the denominator, can also be found in the square of the number, or exponent I mean, the exponent. So by inspection, our u here is the exponent x over 4. So u is just equals to x over 4, and the du of x over 4, or the derivative, is just to 4x cubed dx. Balancing factor. So we all know here this by covering the 4, we can see its du is the same as the equation, but we have an excess here. So by doing the reciprocal of 4 is just 1/4, or you can put here also 4 and 1/4 to balance the equation. So by finalizing, our equation here will become 1/4 the integral of u of e wait, of e raised to u du. So as we all know, or let's recall the exponential formula of EU. It's right here. Let me see it to you guys. So here, the integral of EU du is just equals to e raised to u plus c. So going back to the problem. Okay, so wait, let me adjust my camera. So 1/4 here, the integral of e raised to u du is just equals to 1/4 e raised to u plus c. So by substituting the u here to its original equation, our final answer, let me get a clearer look of that. Our final answer here is 1/4 e raised to x over 4, x raised to 4. You can see that x raised to 4 plus c. So this is how you do general integration techniques. So if you have any questions, you can comment on my video in the comment section, so I can give you a feedback, or you can give me a feedback on how I do in today's lecture. Thank you for listening. So, and our next topic is about trigonometric transformation, I think. Oh no, technique of integration, or integration by parts. So see you in my next video, which is we will be tackling integration by parts. So thank you and have a good day. So good day again, everyone. We are here now to discuss integration by parts. So in this video, at the end of this video, you can learn and master how to solve integration by parts. So first we need is the principles and concept of integration by parts. So first we need the formula, which is the integral need to recall the derivative of u and v. This is u, guys, u is just equals to u dv plus v du. So in derivative, this is the formula, but in integral, this is our formula right here. The integral of u dv is equals to uv minus the integral of v du. So guys, there are two parts you need to find before solving an equation. You need to find the u and the dv. Yes, so this is our formula for integration by parts. So let's start on example. First example here. Is it here ba? Number 1. the integral of let me think of a problem. The integral of, let's say, ln x dx. So first we need to determine the u and the dv here. And guys, quick tip, the dv is located when in the dx part, close to the dx part. I think that is 90% true when the dv is in the dx, but some of your teachers may change what is the u or the dv. So let's get to the problem. U here is ln x equals to ln x, and our dv here is dx. So the du of ln x is just equals to 1 over x, while the integral of dx is just equals to 1 or x, x. Now we apply this formula, so equals to we apply this formula, uv minus integral of v du. So let's do that. U here is ln x and v here is x, but I will make it make the equation by x and ln x minus the integral, or v here is x and our du here is 1 over x dx. So x over x, x dx over x. In the integral of this, we cancel this first, then the integral of dx is just equals to x. So our final answer here is x ln x. Let me get that clear. X ln x minus x plus c. This is our first example in integration by parts. It's easy, right? Yes, very good. So number 2. Wait, let me get number 2. Okay, number 2 here, the integral of, let me think of a problem. 3x raised to e x dx. So reminder guys, are by making a problem here, I am just thinking of a problem that is what comes to mind. So first we need to determine the u and the dv here. So 3x, our u here is 3x, while its derivative is just equals to 3 dx equals, and our dv here is just equals to ex raised to x dx, and the integral of e raised to x is just equals to e raised to x. Alright, now we apply the formula. uv here is to 3x. 3x uv, yes, 3x ex minus the integral of v du here is equals to 3e raised to x dx. So the integral of 3 the integral of 3 ex dx is just equals to, we bring out 3 outside, so 3 x ex 3 raised to x minus ex minus 3. The integral of ex dx is just equals to ex plus c. By simplifying this further, our integral here is just equals to 3x ex raised to x, minus 3e raised to x plus c. So this is our final answer in number 2. So we proceed to the next number, that is number 3. Now guys, this number 3, I will show you a method that I learned from my teacher. So the integral of x raised to 6 e raised to x dx. So the method that we will be using in this problem is the di method, which means d means for the derivative and I di method. The d here is the u, which is x raised to 6, and the I here is the integral of ex. So by doing this, we make the problem easier. So the derivative of x raised to 6 is equals to x raised to 5. By the way guys, wait, let me get a clear look. Okay, so in this method, you need the derivative of your chosen u here. It must be equals to 0. So let's derive the x raised to 6 all the way to the value of 0. So first we do 6x raised to 5. Now 6 times 5 is 30x raised to 4. 30 times 4 is just 120 x raised to 3, x cubed and 120 times 3 is just equals to 360 x raised to 2, and 360 times 2 is just equals to 1080 I think. Yeah, let's check in the calculator. 360 times 2, 720, sorry, 720 x, and the final is 720x is 720 and 0. The integral of e raised to x is just equals to e raised to x all the way to the value of 0. Now in this type of method, you can only use it when the value is a algebraic function or any number that's not complex. So by doing this method, you need to apply the signs, that is just plus, minus, plus, minus, plus, minus, plus, and minus, and you need to multiply each of them in each problem, in each integral, like here. We divide the first to the second number, d1 times I2. So that is a method I just came up. di times I2 and d2 times I3 up to whatever is the last number. So let's do that. Oh, also don't forget the signs, okay? So e times x raised to 6 times ex is just equals to x6 ex, or we can simplify that ex x raised to 6. And then this equals to times that times this to that, this to that, this, and never mind the 0. So equals to negative, also don't forget the signs, okay? Negative 6 x5 e raised to x is equals to 30x raised to the 4 positive e raised to x equals to negative 120 x cube e raised to x is just equals to up to the final, which is 720 times e raised to x. So negative 120 is the next is 360 x squared e raised to x, and negative 720x e raised to x, and just the final number 720 e raised to x. Now we put these values in order. So first is here, first, second, third, up to the last number, you input, and this equals to the last number. Now we do that here. E equals to, get that clear look. So first is ex raised to x minus 6x raised to 5 raised to ex e raised to x plus. You know why I do this, guys? Because according to our teacher, my teacher, it is really long for this to solve, and this method is really helpful for me. So I will now share my knowledge to you about this method, so you will have a better time learning calculus. Okay, negative 6x5 raised to ex plus 30x raised to the 4 ex minus 120 x cubed ex plus, oh no, it is not fit, guys, so we'll put it here down below. So the integral of x raised to the 6 ex is equals to x to the 6 minus 6x raised to 5 ex plus 30 x raised to the 4 ex e raised to x, I mean, minus 120 x cubed e raised to x plus 360 x cubed ex minus 720 x e raised to x plus lastly is 720 e raised to x plus c. So this is our final answer. It's long, right? Yeah. When you do this without the DI method, you will really have a long time solving this type of question. So that's all for today's video about integration by parts. If you have any comments, just put your comments or suggestions in the comment section, and I will see you guys in the future. Thank you for listening and goodbye.